Hello everyone. Our subject for today is Mathematics 10 third quarter week 4. I'm your teacher, Roel R. Rosales Jr. Our topic for today is difference between fermentations and combinations. But before we proceed to our discussion, let's read our learning targets. I can differentiate fermentation from combination of n objects taking R at a time, and relate combination in real-life situation. Player numbers. Shirts have two-digit numbers, 6 possible digits, 0, 1, 2, 3, 4, 5. How many different numbers? 6 times 6 is equal to 36. 6 possibilities for first digit, 6 for second. Suppose double digits are not allowed. You have one of each the numbers. You select 2 and iron the on. How many choices have you for one shirt? 6 times 5 is equal to 30. Fermentations. Order matters. The number of ways one can select 2 items from a set of 6 with order mattering is called the number of fermentations of 2 items selected from 6. 6 times 5 is equal to 30, or write by 6p2. Example, the final night of the folklore festival will feature 3 different bands. There are 7 bands to choose from. How many different programs are possible? On your calculator, enter. Calculating NPR, the solution to band problem 7p3 is equal to 7 times 6 times 5 is equal to 220. There is not the same as asking how many ways are there to choose 3 bands from 7. Write out expressions for 52p4 is equal to 52 times 51 times 50 times 49. 7p6 start 7 is the starting factor and 6 number of factors. So 7 times 6 times 5 times 4 times 3 times 2 is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 7 factorial. Recall the combination. 0 factorial is equal to 1. There are 3 2, 1 is equal to 3 factorial. Arrangements of 3 objects. Using the NPR notation from a set of 3 objects, we are choosing 3. Combination 7C3. In our list of 220 sets of 3 professors, we order mattering. Each set of 3 props is counted 3 factorial is equal to 6 times. The number of distinct combinations of 3 professor is 7C3 is equal to 7P3 over 6 is equal to 7P3 over 3 factorial is equal to 7 factorial over 7 minus 3 factorial times 3 factorial is equal to 7 times 6 times 5 is equal to 220 over 3 times 2 times 1 is equal to 6 is 220 over 6 is equal to 35. 7C3 is the number of combinations of 3 objects chosen from a set of 7. Of 7, take 3. Warning. The combination or sequence of 3 numbers on your combination lock is not a combination. Order matters. What about NP3 and XC3? XP3 is equal to x times x minus 1 times x minus 2. XC3 is equal to x times x minus 1 times x minus 2 over 3. Application to Fokker, Full House. In how many different ways can one have a full house with 6s over 9s. Ways to have 3 6s. Ways to have 2 9s is equal to 4c3. 4c2 is equal to 4 times 6 is equal to 24. How many ways to have a full house? How many ways to have a full house with 6s over? There are 24 ways to have 6 over 9s. Could also have 6 over 2s, 6 over 3s, etc. 12 possibilities for the pair. 24 times 12 is equal to 288 ways to have a full house with 6 over. How many ways to have a full house? Could have 7 over, queens over, etc. 13 possibilities for the triplet. 13 times 24 times 12 is equal to 3,744 ways to have a full house. Stock market example. Suppose 12 stocks have been traded and 7 increased, 3 decreased, 2 stayed the same. In how many ways could this happen? Think 3 separate selections, 3 box problem. Out the 12, 7 increase. Out the remaining 5, 3 decrease. Of the remaining 2, 2 stayed the same. How many 3-digit numbers can be made using only 2 different digits? Numbers must have 2 of one digit, 1 of another. Ways to select repeated digit 10. Ways to select single digit 9 is equal to 90. One selection is made, how many arrangements are possible? Suppose we selected 445, how many places to put the 5? How many ways to choose one of 3 possible locations? 3C1 is equal to 390 selections. 3 arrangements for each 90 times 3 is equal to 270. There are many ways to do these problems. Some are more complicated than others. Sometimes there are shortcuts. Sometimes there are not. Rearrange with repeated letters examples. Example, boss. There are 4 factorial over 2 factorial is equal to 12 distinct. Rearrangement of the letters boss. 4 factorial arrangement if S and S are distinct. If not, cross out repeats. There are 2 factorials equal to 2 rearrangement of S and S. Every distinct arrangement had been counted 2 times divided by 2. Stress. How many distinct arrangements if S, S, and S are regarded as distinct letters? 6 factorials is equal to 720. What if S, S, and S are not regarded as distinct letters? If all the fonts were changed to Arial, how many of the 720 would look like stress? Stress, stress, stress. How many ways can one rearrange SS and 3 factorial is equal to 6? S. The numbers of distinct rearrangement of stress is 720 over 6 is equal to 6 factorial over 3 factorial is equal to 120. Rearrangement of sets containing repeats, as you can see. So that's all for today. Thank you and have a good day.